This is SpaceTime Series 22, Episode 70. Coming up on SpaceTime, the monster at the center of the Milky Way getting active, how nitrogen explosions may have created lakes on Titan, and water has been detected for the first time on a potentially habitable planet. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
There's growing evidence that the supermassive black hole at the center of our Milky Way galaxy is getting more active. The findings, reported in the astrophysical journal Letters, suggest that the monster known as Sagittarius A star is consuming an unusually large meal of interstellar gas and dust. But while that's what's happening, scientists admit they really don't understand why it's happening. One of the study's authors, Professor Andrea Getz from the University of California, Los Angeles, says she's never seen anything quite like this in the 24 years her team have been observing the supermassive black hole. Located some 26,000 light-years away, Sagittarius A star has about 4.3 million times the mass of our Sun. Getz describes Sagittarius A star as usually being a fairly quiet, wimpy sort of black hole, but not lately. The researchers analysed more than 13,000 observations of the black hole from 133 nights since 2003. Images were gathered using the giant 10-metre Keck telescope in Hawaii and the European Southern Observatory's Very Large Telescope in Chile. The authors found that on May the 13th this year, the area just outside the black hole's event horizon suddenly became twice as bright as any previous observations they'd ever seen. And it wasn't an isolated incident. They also observed similar changes, although not quite as big, on at least 2 other nights during the past year. The brightness surrounding the black holes always varied somewhat, but the authors have been stunned by the extreme variations in brightness being exhibited of late, Getz describing it all as being completely unprecedented. The brightness, the scientists have observed, is being caused by radiation from gas and dust as it falls onto the black hole's accretion disk, where it's torn and ripped apart at the subatomic level and then crushed, creating huge amounts of friction, in the process releasing heaps of energy, sort of like a last dying scream, before passing beyond the event horizon, a sort of point of no return beyond which nothing, not even light, can escape the black hole's immense gravitational field. The ill-fated material then falls forever into the black hole's singularity, a place where science's very understanding of physics starts to break down. The new observations have Getz and colleagues asking whether this was an extraordinary singular event, or whether it's just a precursor to significantly increased activity. The study's lead author, Tuan Do, also from the University of California, Los Angeles, says the extreme increase in brightness caused the authors to initially mistake the source for the star S22, but it quickly became clear that it was in fact the black hole itself. So the big question is whether the black hole is entering a new phase. For example, if there's a vast amount of gas and dust that's now falling into the black hole's drain, and will do so for an extended period of time, or whether we've just seen a few fireworks associated with a few isolated blobs of gas falling in. Naturally, the authors are continuing to carefully monitor the region to try and settle that question based on what they can see from new images. One hypothesis about the increased activity is that when this star S02 made its closest approach to the black hole during mid-2018, it may have had a large quantity of gas ripped off it. That gas is now finally reaching the black hole's event horizon. Another possibility, however, involves a rather bizarre object known as G2. Now, this was originally thought to be a giant cloud of gas and dust. G2 made its closest approach to the black hole in 2014. Astronomers were expecting a spectacular light show at the time as Sagittarius A star ripped material from the object, consuming it and releasing huge amounts of energy in the process. The trouble is, strangely, nothing happened. A bit of a letdown for astronomers, really. We spoke about it numerous times on SpaceTime's predecessor Star Stuff. Following that, non-event, astronomers decided G2 might not be a gas cloud after all. Instead, it could be a pair of binary stars, orbiting so close to each other that they're sharing their atmospheres and therefore appearing to be a large gas cloud rather than 2 separate stars. If that's the case, then Getz thinks it's possible the black hole could have stripped off the outer layer of G2, and it's that outer gaseous envelope which could be explaining the increased brightness which is now occurring just beyond the black hole's event horizon. Of course, there are heaps of other possibilities as well, such as large, dense asteroids or even planets being drawn into the black hole. A mystery for sure, one scientist hoped to resolve. I'm Stuart Gary. You're listening to SpaceTime. New research suggests that lakes of methane found on Saturn's largest moon Titan may have been formed by pressurized nitrogen exploding from just below the moon's surface. The findings, reported in the journal Nature Geoscience, are based on data gathered by NASA's Cassini spacecraft during its 20-year mission to the Saturnian system. Titan is an amazing place. It's the only known world other than Earth to have streams and rivers flowing down into lakes and oceans. However, unlike Earth's water-based hydrological cycle, Titan's liquids are methane and ethane. You see, Titan's so cold, water there is frozen solid, forming much of the moon's bedrock. One of the study's authors, Professor Jonathan Lenine from Cornell University, says Titan has very distinctive topography. Its lakes show different kinds of shapes and, in some cases, very sharp ridges. Lenine and colleagues decided to study these lakes in greater detail, examining their steep, cratered sharp edges, raised rims and ramparts. In fact, some of these steep ridges tower far above the moon's natural liquid sea level. Lenine says the features look like something's exploded out from below. And the best explanation for that is a gas that either ignites explosively or a gas that builds up enough pressure so that it just pops out like a cork from a bottle of champagne. On Titan, there's nothing that would create a fiery explosion because the moon has no free oxygen. So a pressurized explosion model best fits the kind of event that would create the crater-like structures seen on Titan. Later, those same craters would be filled with liquid methane and ethane as it rains down and flows in from higher ground. But what about the source for the explosion in the first place? Well, Titan's atmosphere is filled with vaporized nitrogen. In Titan's geophysical history, the moon's seen epochs where methane becomes depleted, leaving a nitrogen-rich atmosphere. The nitrogen cools, producing nitrogen liquid rain in the frigid climate, which then falls onto the ground, soaks in and collects in pockets under Titan's crust. While Titan is a long way from the Sun, nevertheless a slight amount of geological heating probably occurs that causes this pressurized gas to explode, popping out onto the surface. And in the moon's natural cycling process, liquid methane then returns and fills in the craters, forming lakes. To find out more, Andrew Dunkley is speaking with astronomer Dr. Fred Watson.
They've made a bit of a discovery about the lakes on Titan. This is fascinating.
I think it is too. It's work done by an international team of scientists, and in fact they're led by an Italian planetary scientist, Giuseppe Mitri. He and his team have looked afresh at some of the information that has come back from Cassini actually during its final flyby of Titan. This was really right at the end of the Cassini mission, which ended almost exactly 2 years ago. So what has happened is that these scientists have used the radar imaging data that has come back from Cassini. Remember, Titan's got this thick atmosphere, or pretty opaque atmosphere, which is laced with hydrocarbons, smog, and that prevents visibility directly down to the surface, except under rather special conditions. You can do it with infrared at certain times of the Saturnian year, but radar is the way to do it. So the radar images that have been analysed show a feature of the smaller lakes, which, like all the seas and lakes of Titan, are predominantly around the North Polar region of the moon. So the smaller lakes seem to have these rims around them that stand much higher than the lake level itself and higher than the surrounding landscape. So it's almost like a wall around these lakes, up to tens of meters high, maybe hundreds of feet high. They're not little things. They're really significant structures.
Which would be easily explained if it was a gorge or something, but it's a lake.
Yes, that's right. It's a lake. And the key thing is that the larger seas don't show these. The larger seas, which are bigger than the Great Lakes of America, they're bigger than the biggest freshwater lakes on Earth, they don't have these features. They do have very well-defined edges, very well-defined shorelines, if I can put it that way, but they don't have these rims around them, which only the smaller ones do. And so that's caused a lot of head scratching as to why this should be the case. and that's just been published actually within the last few days, that essentially the feeling is that the bigger seas formed by methane pooling in the icy surface of Titan. Remember, the surface is not rock, it's solid ice.
Yeah.
And so if you get undulations in that, the methane pools in it, and the certain circumstances, the methane can actually eat into the ice. So what you get is a situation where you get an ever-growing sea or lake, and around the edge of it, there's just a standard kind of boundary, just a normal shoreline. But the speculation about these ones with the rims, the smaller ones, is that they are caused by explosions, not kind of chemical detonations, but physical explosions of nitrogen, which has been liquid, suddenly turning into a gas underneath the surface of the ice,
okay,
blowing off the surface. I was
thinking the opposite. I was thinking some kind of impact, but it's come from underneath. It's blown out.
That's the feeling, yes. So there's basically a story to tell that the atmosphere of Titan is a really good greenhouse gas atmosphere and keeps Titan warmer than it otherwise would be, even though, its surface temperature is still, I think it's about minus 180, minus 190 Celsius. It's very cold. But if you've got a slow climate change on Titan, there's been periods where it's been slightly warmer, periods where it's been slightly cooler. And the thinking is, when Titan is cooler, you've got a nitrogen cycle in the atmosphere. So you get nitrogen rain, nitrogen evaporation, and the thinking is that the nitrogen has collected in pools sort of beneath the surface, underneath the icy surface of Titan, almost like a kind of water table, but with nitrogen rather than water. And then the suggestion is that if you've got these masses of liquid nitrogen in the crust of Titan, if you get some warming, then that liquid nitrogen vaporizes, expands pretty quickly and blows out a crater, which has rims. And that's a very interesting and new analysis of what we see. There's actually a lovely comment from the Cassini project scientist herself, Linda Spilker of the Jet Propulsion Laboratory. What Linda says is this is a completely different explanation for the steep rims around those small lakes, which has been a tremendous puzzle. As scientists continue to mine the treasure trove of Cassini data, we'll keep putting more and more pieces of the puzzle together. Over the next decades, we will come to understand the Saturn system better and better.
That's Professor Fred Watson, an astronomer with the Department of Science, speaking with Andrew Dunkley on our sister program, Space Nuts. And this is Space Time. I'm Stuart Gary. If you'd like to help support SpaceTime and the great work we do promoting science, then why not come and join our Patreon family? For just a few dollars a month, you'll get access to a slick commercial-free double-episode version of SpaceTime every week, as well as extended interviews not included in the show, and an invitation to join our special Patreon-only Facebook group where you can come and chat, discuss the show, ask questions, whatever you want with like-minded listeners and our team. You can get all the details at patreon.com/spacetime with Stuart Gary, where you can see the various reward levels we have and what works for you. And of course, most importantly, you'll be helping to support our show and the work we do to deliver the wonders of the universe to everyone. Now that URL again is Patreon, spelled Patreon, patreon.com/spacetime with Stuart Gary. And of course, you can find the details in the show notes or just click the orange button on our website. And thanks to all our patrons, because it's your generosity and support that helps keep our show going. Water vapour has been detected for the first time in the atmosphere of a habitable zone exoplanet. The planet, designated as K218b, is a so-called super-Earth with about 8 times Earth's mass. It's orbiting a spectral type M red dwarf star known as K218, which is located about 110 light-years away in the constellation Leo. The discovery, reported in the journal Nature Astronomy, represents the first successful atmospheric detection of water for an exoplanet orbiting in a star's Goldilocks zone. That's the region around a star where it's not too hot and not too cold, but just right for water, essential for life as we know it, to pool on a planet's surface. The study's lead author, Dr. Angelo Saris from the University College London, says finding water in a potentially habitable world other than Earth is incredibly exciting. Now, don't get us wrong, K218b is not Earth 2.0. It's significantly more massive with quite a different atmospheric composition. However, it does bring science a step closer to answering that fundamental question, is the Earth unique? The authors based their discovery on archival data captured by the Hubble Space Telescope and then developed open-source algorithms to analyse the starlight being filtered through K18b's atmosphere. And the results revealed the molecular signature for water vapour, also indicated with the presence of both hydrogen and helium in the planet's atmosphere. The authors believe other molecules, including nitrogen and methane, are probably also present there as well, but with current observation methods, they remain undetectable, at least for now. Further studies will be needed to estimate cloud coverage and the actual percentage of atmospheric water present. Now, before you get too excited, remember, this is an M-class dwarf star, and like all red dwarfs, it has a high level of stellar flare activity. And that would likely mean a very hostile environment for anything exposed on the surface of a planet orbiting the star. Lots of radiation and lots of stellar wind activity as well. So far, more than 4,000 exoplanets have been discovered. K218b was first detected in 2015 and is one of hundreds of super-Earths, planets with masses between that of the Earth and Neptune, found by NASA's planet-hunting Kepler Space Telescope. Interestingly, although there are no super-Earths in our solar system, at least none that were found yet, Planet 9, if it's out there, may be the exception. From what we can tell, super-Earths are the most common type of planet detected so far in our galaxy, just like M-class red dwarfs are the most common type of star in the galaxy. And that means the K218 system should be fairly representative of what else is out there. NASA's recently launched TESS mission is expected to detect hundreds more super-Earths in coming years. I'm Stuart Gary. This is SpaceTime. And time now to take another brief look at some of the other stories making news in science this week with a science report. Short people may be at higher risk of developing type 2 diabetes. A report in the journal Diabetologica has found that for every 10 centimetres taller someone is, their risk of developing type 2 diabetes drops by 41% for men and 33% for women. The link is largely related to leg length in men, which researchers say may indicate that growth before puberty could have a far more favourable impact on the risk for diabetes than growth during puberty. The authors say that some of the link between height and diabetes risk may be explained by high levels of liver fat or other diabetes and heart disease risk factors in shorter people. The authors suggest that short people should be monitored for both diabetes and heart disease risk factors more frequently than taller individuals. A new study has found that dolphins living in the English Channel have some of the highest levels of mercury concentrations ever found in their species. The findings, published in the journal Scientific Reports, shows that while bottlenose dolphins have one of the largest coastal populations in Europe, they're paying the price, with pollutants such as mercury and other industrial fluids accumulating in their skin and blubber. Although many pollutants were banned in the 1970s and 80s, many can still be detected even in the deepest marine life, and researchers say dolphins living in the English Channel need special protection. Paleontologists have identified a newly discovered species of pterosaur, which may be one of the largest ever flying animals. A report in the journal Vertebrate Paleontology says Cryogekenboris, which lived during the Cretaceous period around 77 million years ago, had a wingspan of up to 10 metres. That's as big as a light aircraft. Fossils from the flying reptile were discovered 30 years ago in Alberta, but paleontologists wrongly identified them as belonging to an already known species of pterosaur discovered in Texas. This discovery provides scientists with a better picture of the diversity and evolution of predatory pterosaurs during the age of the dinosaurs. Well, it seems that decades after the Dead Sea Scrolls were first discovered in the desert caves of Qumran, the ancient manuscripts are still offering up new surprises. A report of the journal Science Advances claims chemical analysis of the Temple Scroll, the longest of all the scrolls, shows that it has a salty coating on the text side, something not found on any of the other Dead Sea Scrolls. The unusual finish suggests that the Temple Scroll's remarkably bright parchment was manufactured differently from the other documents in the collection. The Dead Sea Scrolls are ancient Jewish religious manuscripts found in the Qumran caves in the Judean desert on the northern shore of the Dead Sea. The various scrolls in the collection have been scientifically dated from 2,300 years for the oldest to the 1st century of the Common Era for the newest of the manuscripts. This is the time of Christ and the time of the second Jewish temple in Jerusalem, which was destroyed by the Romans, who then banished the children of Israel from their homeland. The texts have great historical, religious and linguistic significance because they include the second oldest known surviving Hebrew manuscripts of works later included in the Old Testament, the Jewish Bible. Researchers studying playful behaviour in animals have successfully taught rats how to play hide and seek, and it turns out the rodents are pretty good at it. A report in the journal Science says researchers spent weeks teaching the rats how to play the game, both the hiding and seeking parts, and then rewarding them with tickles and pats when they got it right. Though it all sounds like frivolous fun, the researchers say it's typically hard to study this kind of playful behaviour in animals. But their study has found that rats do become more strategic in the game over time, staying very quiet when hiding, changing their hiding locations, and even checking out past hiding spots when seeking. How many times have you been out with people and some fool who knows nothing but thinks he's got all the answers because he read it on Facebook tells you climate change isn't real, the moon landings were faked, or vaccines cause autism? They then start rolling out a long list of inaccurate or cherry-picked examples to support their argument, which either came from people who aren't experts in the field or which simply isn't scientifically correct. And all the time you're left sitting there, expected to provide peer-reviewed scientific studies off the top of your head to shoot down every half-remembered claim they make. Tim Mendham from Australian Skeptics says technique rebuttals are a particularly effective and economic tool when dealing with scientific deniers. Point out their cherry-picking, their lack of peer-reviewed scientific evidence, or the use of scientists who aren't really experts in the field. Now, I've found that especially useful when scientists denying climate change turn out to be funded by mining companies.
How do debaters science deny? It is the $64 question, obviously, for everybody who needs to cope with someone who either comes along and says vaccines don't work or the moon landing was a fake or blah, 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 the paranormal exists, etc., and, science doesn't know what it's talking about. There's two different ways to approach it. One is to approach what they're saying, the claims, the facts, and you can have the tendency to come across as just a naysayer. It's very hard for an individual to be an expert on every topic. I know that for a fact because I get asked about a whole range of different things. So when one person with a speciality of a particular sort of pseudoscience comes to you and throws 3,000 different facts, in quotes, at you, it's very hard to respond to all of them. The other thing is to look at the way that the argument is being put forward, and this is something which is more general among science deniers. It's not as specific as a topic that they might know well. It's the same techniques that are used, the same cherry-picking techniques, logical fallacies, a whole range of different things. Basically, it's the underpinnings, it's the meta, if you like, of the argument, which you can then sort of view and say, well, what you're doing there is sort of using a circular argument or all sorts of different logical fallacies, which you can look up, and sort of skeptics have been covering these things ever since the skeptics existed, as to why people propose these things and why they believe. And some of it is just if you can sit there and point out that there is an error in the process, in the method they're using, and that applies to people across the board in many, many different areas of scientific denial, that might be more effective than just a straight out, no, you're wrong, and this is what I say is the fact. Because people will just say, well, that's what you say. But if you can say that, well, what you're doing here is you're picking out little things here and there, you're not looking at the whole picture, etc., and that might be more effective. It is a tough area. In either case, a lot of people don't like debating with science deniers because
if they win, they've always got another argument.
Well, you can never win, and you can lose easily, right? Because if they sort of throw 3,000 things at you in one go, like what's called the Gish Gallop, or we just go blah 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 blah, and you're trying to keep up, or if they throw you a curly one, something you've never heard of, and you can come across as looking like you do not know. And it only takes one do not know for a science denier to say, you're an unreliable source. Whereas if you had to debunk everything on a particular topic that a science denier says, you're on a hide into nothing, really. So a lot of people I know will not debate anti-vaxxers, for instance, because it's just not worthwhile, and it sort of also gives them the imprimatur that they are worth debating. But I think this is mainly dealing with not so much a professional anti-science person, but the ordinary members of the public, the friends, the family, the story over the dinner table, where you might be dealing with someone who has a totally different view, and then you have to know how to deal with it without having a fight, without someone throwing a bun at you.
That's Tim Mendham from Australian Skeptics. And that's the show for now. You can subscribe and download SpaceTime as a free twice-weekly podcast through Apple Podcasts, Stitcher, Bytes.com, Pocket Casts, SoundCloud, YouTube, Audioboom, from spacetimewithstuartgary.com, or from your favourite podcast download provider. SpaceTime is also broadcast coast to coast across the United States on Science 360 Radio by the National Science Foundation in Washington, D.C., and around the world on iHeartRadio and TuneIn Radio. If you want more space time, check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as loads of images, news stories, videos, and things on the web that I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word and in lowercase, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTime with Stuart Gary on Instagram. On Facebook, just go to www.facebook.com/SpaceTime with Stuart Gary, and you can also find us on the SpaceTime with Stuart Gary YouTube channel. SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.